a spectacular nova is poised to illuminate the night sky soon, visible to the naked eye from Earth. This anticipated event will occur in the constellation Corona Borealis, known as the Northern Crown, promising a breathtaking display that can be seen clearly, even amid city lights. The upcoming nova event in T Corona Borealis, TCRB, known as the Blaze Star, is a highly anticipated celestial spectacle. This binary star system, situated about 3,000 light-years away in the constellation Corona Borealis, consists of a red giant star and a white dwarf orbiting each other every 227 days. Historically, TCRB has exhibited periodic nova outbursts, dramatically increasing in brightness and becoming visible to the naked eye. The last recorded outburst was 8 years ago, with previous notable events in 1866 and the 1940s. Astronomers predict the next outburst could occur between April and September this year, offering a rare opportunity to witness this extraordinary astronomical event firsthand. Such occurrences are infrequent in the Milky Way, making each observation crucial for advancing our understanding of stellar evolution and the dynamics of binary star systems. To know more about TCRB, stay with us till the end of the video. A nova is a dramatic event where a star suddenly increases significantly in brightness, typically occurring in binary star systems featuring a red giant and a white dwarf. These systems play a pivotal role in the nova process due to the interaction between the two stars. TCRB exemplifies a recurrent nova where a white dwarf pulls hydrogen-rich material from its larger companion, the red giant. This material forms an accretion disk around the white dwarf, gradually accumulating on its surface. As hydrogen accumulates, the temperature and pressure escalate, sometimes reaching extreme levels of up to 10 million Kelvin. The intense heat within the accreted material triggers rapid nuclear fusion reactions, transforming hydrogen into heavier elements like helium and oxygen. This process releases an immense amount of energy, manifesting as a sudden burst of light and the expulsion of material from the white dwarf's surface into space. This cycle repeats cyclically, with the white dwarf gradually accumulating more material until the conditions are ripe for another outburst, typically occurring every 10 to 100 years. In contrast to recurrent novae, dwarf and classical novae share similarities in their process of hydrogen accretion onto a white dwarf. However, classical novae are much less frequent, with occurrences spanning tens of thousands to hundreds of thousands of years. The specific reasons behind these differing frequencies remain a topic of ongoing research, but factors such as the mass of the white dwarf and the rate of material accretion from its companion star likely play crucial roles. Studying these diverse types of novae provides fundamental insights into stellar evolution, the dynamics of binary star systems, and the broader processes shaping the universe's structure and composition over cosmic timescales. Dwarf novae occur due to instabilities in the accretion disk around a white dwarf, unlike the mechanisms behind recurrent and classical novae. It's important to distinguish novae from supernovae, which are much more powerful and mark the end of a star's life cycle. Supernovae occur either when a white dwarf in a binary system accumulates enough material to explode catastrophically, type 1a, or when a massive star collapses, type 2, resulting in an explosion that can outshine entire galaxies and often forms neutron stars or black holes. Unlike novae, supernovae do not recur in the same star system. While both involve bright explosions, supernovae involve complete destruction, whereas novae do not harm the white dwarf and play a lesser role in cosmic element distribution. Astronomers have been closely observing TCRB for the past 8 years, noting consistent signs of unusual outbursts. Normally a faint star with an apparent magnitude of 10, TCRB appears dimmer than Neptune in the night sky. Apparent magnitude measures how bright a star appears from Earth, with lower numbers indicating brighter objects. For instance, a star with magnitude 2 is 500 times brighter than one with magnitude 10. Under optimal conditions, the human eye can see stars up to magnitude 6 in clear, dark skies. TCRB gained renown in 1866 after a notable brightening event, and it has been under constant scrutiny since. Another significant outburst occurred in 1946, increasing its brightness from magnitude 10 to magnitudes 2 and 3, respectively. Similar levels of brightness are anticipated for the upcoming nova event. Astronomers have meticulously documented the star's phases and anticipate the next chapter in its observable history. In the past 8 years, astronomers have noticed T Coronii Borealis behaving similarly to its pattern before the 1946 outburst. Notably, from 2015 to 2016, TCRB's brightness surged, echoing its behavior in 1938, which preceded the significant 1946 event by 8 years. These observations suggest the star was entering a highly active phase. More recently, in 2023, TCRB's brightness notably decreased to levels similar to those observed in 1945, just before the last major outburst. This recent dimming further indicates that TCRB may be on the verge of another significant outburst, expected in 2024. This cycle of brightening and dimming is part of the star's natural rhythm, aiding astronomers in predicting its future behavior. The key question now is where to look in the sky to witness this rare event. Normally faint, TCRB will briefly shine brightly during its nova phase, becoming visible to the naked eye as a bright star in the constellation Corona Borealis. After this period, it will gradually fade and remain out of sight for another 8 years. To observe the outburst, locate the Big Dipper in the Ursa Major constellation. Follow the handle of the Big Dipper until you reach the U-shaped Corona Borealis or Northern Crown constellation. Alpha CRBs is the brightest star in this constellation. Moving eastward along the curve from Alpha, you will pass Gamma CRB and Delta CRB. TCRB lies approximately 2.2 degrees east of Delta CRB during its nova phase. During its peak brightness, TCRB is expected to shine as brightly as Alpha CRB. While normally not visible to the naked eye, TCRB can currently be observed using telescopes or binoculars. Alternatively, you can explore TCRB in the NASA Skyview Virtual Observatory, where various images taken by advanced telescopes are available across different wavelengths. If you are about to watch this happening, then let us know, how are you planning to do so? Comment below, we like to hear from you. Do like this video if you have learnt something interesting from it and share it with friends and family. Subscribe to our channel for more such interesting content on space science. We will meet you in the next one.